All over the world, frogs and toads have been suffering population declines in recent years. In California, the most heavily hit populations live in the state's mountains. In this section of Cal Alive, you'll become part of a frog rescue team that's trying to discover the causes of decline in 4 different amphibian populations. In the first experiment, the team will be there to help you all the way. But you'll move up to become assistant researcher for the next 3 experiments, so pay close attention.
Oh, thank goodness you've arrived. We really need your scientific expertise to help us find out why all these wonderful frogs in the California mountains are disappearing.
The one our Sierra chapter is most worried about is the mountain yellow-legged frog.
Check out all these newspaper articles. It's really getting serious.
Do you see the article? Read down to the section on declining populations.
Let's record this data on the chalkboard.
What do you think is happening?
Oh boy, here come the yellow index cards. Okay, so we need to think about how to state the problem.
Yes, you need a problem statement.
Let's summarize the information from the table. Oh, that's what the yellow cards are for.
Bobby writes, all yellow-legged frogs are extinct.
Well, if you look at the right side of the graph, you will see that there are still frogs in Crystal, Diamond, and Emerald lakes.
Here we are at the University Research Lake where there are no trout. We can do our experiment here because research is permitted. What could you do here to test whether trout cause frog populations to decrease?
I know. Add grown trout to the lake.
Yes, but we have to have some kind of a control, where there are frogs in the same lake, but no trout.
Let's divide the lake in half with an underwater fence.
Let's label the left side of the lake A and the right side B. This way we can compare the frog populations on both sides.
Be sure that there's the same number of frogs in each side of the lake.
And then add trout to one side of the lake, but not the other.
Allow the frogs to mate and lay eggs. Start counting the tadpoles and the adult frogs on both sides of the fence.
Let's watch what happens over time.
Let's look at this spinning globe of the Earth. Notice that most of it is covered in water. Did you know that more than half of the Earth is covered by seawater? In fact, the ocean covers more than 70% of the Earth's surface. No wonder people call it the water planet, or the blue planet. Do you see the Pacific Ocean and the other ocean basins? There is really only one ocean on Earth because all the major seas interconnect. This is why you can sail a ship around the world. But if there's only one ocean, then what are those 7 seas we hear about? These actually refer to ocean basins. An ocean basin describes the shape of various seas. Today we recognize 5 ocean basins: the Pacific Ocean Basin, the Atlantic Ocean Basin, the Indian Ocean Basin, the Arctic Ocean Basin, and the Southern Ocean Basin. Even though there's only one ocean, water still moves around the globe, and it does so through currents. A current is a stream of ocean water which moves in a regular pattern. Winds, temperature differences, the amount of salt in the water, and the rotation of the Earth all affect the direction and shape of currents. There are two types of currents that move ocean water: surface currents and deep currents. Surface currents move water horizontally at the surface of the ocean. They are affected by winds and the Earth's rotation. Deep currents occur far below the ocean's surface. They move water vertically, depending on the water's temperature and salt amount, which affects the overall density of water. But we'll talk more in depth about deep currents later. For now, let's focus on what occurs at the surface. This overall movement from surface currents to deep currents and back again is called the global conveyor belt. Here we see the global conveyor belt in action. Notice how the lines flow around the ocean basins, circulating water throughout the entire ocean. See if you can spot where the two currents mix. Notice how all the northern hemisphere winds are moving to the right of their original wind direction. Winds that would blow to the north without the Earth's rotation are now moving northeasterly, and winds that would blow to the south without the Earth's rotation are now moving southwesterly. And in the southern hemisphere, you can see the winds are moving to the left from their original wind direction. So now that we understand the processes
Aunt Margie! Aunt Margie!
Alex! You're here! I'm so excited to see you!
I'm here, but why'd you want me to meet you here?
You're going to love this! Allow me to introduce you to my newest invention, the Margie 2, or M2 for short.
Whoa!
M2, this is Alex.
Hello, Alex. It is a pleasure to meet you.
It's nice to meet you too, Margie 2.
What do you think?
What is it?
It is a research vessel designed to collect information from severe storms.
Can this thing fly?
M2 is not a thing. She is a highly advanced, fully functional artificial intelligence capable of reasoning and logic. And yes, Alex, she can fly.
How does it fly? I don't see a propeller or anything.